Page 413, number 7. Determine the value of x and round your answers to 2 decimal places. So we're solving for x here. So the first thing we want to do is we want to identify the base. And for a, we can see that the base is 7 and the base is 2. So that tells me right away that these are unrelated bases, which means that we're going to have to either express our solution as logs, or we can calculate the log values and give a decimal place answer. In this case, we're going to solve it as a log, and then we're going to put it into our calculator to get the decimal place answer. So we're going to need to use logs here because we have x in the exponent, and there's 2 ways to introduce logs. We could either write this as an exponent, convert the exponential expression into a log expression. In this case here, it's a little bit complicated because we have our exponents on x's on both bases. The other way we can do it, which is a little bit easier in this case, is to just log both sides of the equation. So if I introduce a log this way, I get log, and I'm just going to use base 10 for argument's sake. We could use either base 10, base 7, or base 2. Okay, they all will work. I'm going to use base 7 or base 10 just to keep things simple. I want to bring that exponent down to the front. Okay, so I'm going to do the same thing here. I'm going to log this side of the equation, and I'm going to bring that exponent to the front as well. When I do that, I end up with 2x log 7. And when I bring that exponent down, since it's a binomial, make sure that you keep that grouped together in brackets. And this is log base 10 of 2. Now I'm solving for x's. This is just an algebraic equation solving for x's now. If I want to solve for x's, I need to get x's on both sides. Well, to do that, I first need to expand out the brackets on the right. So I get x log 2 plus 3 log 2. I want to group the x's together on the same side of the equation, so I end up with 2x log 7 minus x log 2, and that's equal to 3 log 2. I want to solve for x, so I need to get 1x. If I have 2 x's and I want 1x, I want to factor to get that 1x. So I'm going to factor that out. 2 log 7. Again, these are just 2 log 7 is just a number. Same with log 2. We can work out the decimal place number for this, but that's going to make it a little bit sloppy looking, so we're just going to keep it in logs. So some number times x equals another number on the opposite side. So I need to get rid of that multiplier, the log, that everything in the brackets, by dividing both sides by that whole thing. Okay, so I'm going to divide by 2 log 7 minus log 2. Okay, so that's my base 10 answer. I could have done this in base 7 or base 2. It doesn't matter, and I could have even used the definition of log to introduce the log in this problem. So when I work this out, I get 3 log 2 divided by 2 log 7 minus log 2, and I get 0.650. Okay, so x is equal to 0.650. Okay, so there's lots of different ways to do this. So this is just one possible way of doing this problem. So I'm going to also do example D, number 7D. So I've set this up here. Now, to be able to solve this, again, I have to either introduce a log, or by definition of log, or I can log both sides to introduce the log. Now, since we introduced the log by logging both sides in part A, in the equation, or 7a, maybe we will do this one by using definition of log. So this is a little bit harder for this particular problem, but we'll try it anyways. So we're going to say that this is the argument. we're going to say that this is our exponent and that this is our base. Okay, and then we're going to rewrite it with the log expression. So I'm going to say log base 9. The argument that is going to be 4 times 7x plus 2. And that's going to be equal to the exponent, which is 2x. The exponent is 2x minus 3. So to solve for x, we need to get this other exponent out of the x out of the exponent. Now, we can't use that power rule to get that out right now because there's that extra 4. So what we're going to do first is we're going to split this up. So log base 9 of 4 plus, and then we're going to bring that exponent down. So x plus 2 log base 9 of 7. And that's going to be equal to 2x minus 3. Okay, so I split those logs up into two parts. So I have this part here, and I have this part here. And when I did that, I've kind of done 2 steps in one. I brought the power to the front. So again, the goal is to solve for x. So I need to group my x's. So I'm going to put all the x terms on one side. To do that, I need to expand out the brackets first. So I'm going to end up with x log base 9 of 7 plus 2 log base 9 of 7, and that's equal to 2x minus 3. Okay, now bear in mind that we can actually, this is a number, this is a number. If we want to deal with a messy looking decimal number, we can work that out. Same with this is a number. Those are all just messy decimal numbers. We're not going to deal with the decimals. We're just going to keep it in expressions so that we can do this a little bit more cleanly. So I'm going to keep all the number terms on the left-hand side. In fact, I'm going to make this I'm just going to put that power into here and square it, and I'll just do 1 log on the left-hand side. And this is going to be x log, let's move that 3 to the other side. We don't want that 3 here, so we're going to go plus 3. And this is going to be equal to 2x minus x log base 9 of 7. Okay, I need to solve for 1x, so I'm going to factor the x out. Okay, and again, that's all that represents some number. Same here, this is all just one number, but part of it's in logs. I'm going to group those logs together. So 4 times 49 is going to give me 196. And then plus 3 is outside of that log. Okay, and then solving for x, my answer is going to be log base 9 of 196 plus 3. Okay, again, that 3 is not part of that log. And I'm going to divide by 2 minus log base 9 of 7.